Okay, so today we're going to go through the correction steps for last night's homework. Remember, again, you don't need to watch every moment of this video, even though you love the sound of my voice. You can forward through. If it was me, I would fast forward through the first, say problems 1, 3, and 5. Look at the answers to those. If I had them right, then I'd move to the next ones. If I didn't have them right, then I'd go back and I'd check out the work. All right, so here we go. Problem number 1. Now remember, what we're doing here is we're looking for a way to find compatible numbers that allow us to quickly see answers. So in problem number 1, I'm going to take the 47% and I'm going to make it 50%. I'm going to keep the 70 the way it is. So what I'm saying is 50% of 70. This is one that, for me personally, it's easiest to think of as a fraction. That's half of 70, and half of 70 is 35. You could have taken that 50%, and you could have said, well, if I'm taking 50% of 70, I know that 10% of 70, since we're not using number 2, I can use this space. I know that 10% of 70 is 7, and then I would have, since it's 50%, I would have 5 groups of 7. There's another way to see 35. Number 3, 21%. I'm going to think of that as 20%. By the way, I just want to go back for a moment. This 35, I know that 35 is a little more than the actual. And I know it's a little more because I rounded up, which means when you round up, the answer you get is higher than the actual answer. If you round down, that's what I'm doing in number 3, the answer you get is smaller than the actual answer. So I'm going to do 20% of 90. I'm going to use this idea that 10% of 90 is 9. So 20% of 90 is 2 groups of 9, which gives me 18. That's my 20% of 90. Now I know that 18 is actually a little smaller than the actual because I rounded down. I didn't round down by much, only 1%, but still I know my 18 is a little bit smaller than the actual amount. Moving on to 72% of 238. This is an example of a problem where you're going to do some rounding on both sides. I'm going to take these two together, and I'm going to look at it and say, all right, 238 is almost 240. So I'm going to round that to 240. Then I'm going to look at my 72, and I'm going to say, all right, so I need to do some amount. I can pick. When I'm at 72%, I might select 70%, or I might select 75%. 72% is just about in between those two. If I do the 70%, I'm going to go to the idea of 10% is 24, and then I do 7 of those. That's okay, but if I go to the 75%, then what I'm saying is how much is 3/4? And 24 is a number that I can divide by 4 evenly, which means 240 divides by 4 evenly. So I would look at this one, and I would say, all right, well, 240. If I was doing 24, let's use the space over here in number 4. If I was dividing 24 by 4, I would get 6, which means if I'm dividing 240 by 4, I'm going to get 60. So I'm going to think of this problem as 75% of 240. Then I'm going to take my 240, divide it by 4, and get 60. I don't want that to be an equal sign. Let's make that an arrow. That 60 is 1/4 of 240. I need 3/4 of 240. Right here, it's saying we've got 3/4. So I'm going to take the 60, multiply it by 3. 6 times 3 is 18, so 60 times 3 is 180, and that's my answer. You might think, well, that's great, Mr. Wilmarth. You know all that stuff. And that's true. And you will get better at this as you do more of it. You'll start looking at these numbers and you'll say, okay, what makes a logical grouping here or a logical rounding here? Doesn't mean you're going to be great at it right away, and that's all right. You get better as you go. And this was a big problem. We're gonna stay away from these big problems on any testing for a while, but it's good to see the big problems to know the direction that you're headed. All right, let's go with 224% of 320. So again, I'm going to look at this and ask myself, all right, what am I going to do with this 224? What am I going to do with this 320? Let's see what would happen if I went 225% here. So if I go 225%, I can think about breaking that down into 200% and 25%. 320, now again, 25% is a fourth of something. So I'm going to, as I'm doing this, I'm thinking, okay, that's a fourth. 320 is a number that, again, can be evenly divided by 4. And the way I know that, other than I'm a brilliant math teacher, which I'm not really, but the way I know that is 32 can evenly be divided by 4 into 8, which means 320 can be evenly divided by 4 into 80. So then what I'm looking at is my 200%. Remember that 100% of anything is what you start with. So 100% of 320 is 320. So 200% of 320 is 320 2 times. So 2 300s are 600, and 2 20s are 40. So I've got 640. I just said 25%, that 1/4 right over here, 320 divided by 4, that's 80. And then I'll put my 80 and my 640 together. 4 and 8 is 12, so 40 and 80 is 120. So 20, and there's the 100 part, and I have 720. Again, that's a big problem. That's not the problem you're going to see on any kind of a test. Or if you did see it on a test, I would probably make that an extra credit problem. But it's good to see the types of things you're going to work on. All right, let's move over to number 9. And if at any point you need to pause the video for just a minute and catch up on notes, or pause the video and catch your breath, feel free to do that. Okay, problem number 9. So number 9 is, again, a problem where I'm going to be doing some rounding work on both of these. First off, I'm going to think of this 510 as 500. That makes it a lot easier for me to work with. And then I'm going to think of this 0.4% as 0.5%. So now I've got 0.5%, which means I can go through, and let me just write that down. That's the same as having 0.5%. So then I can take my 500 and I can say, all right, so what's 10% of 500? That's 50, which means 1% of 500 is 5, and I need 0.5% of that. So if 1% is 5, then 0.5% of 500 is 1/2 of 5. It's 2 1/2. Again, you'll get better at these as you see more of them, as you have more practice at them. Number 11. The United States has 12,383 miles of coastline. If 0.8%, that's, so 0.8% is the same as saying 0.8%. If 0.8% of the coastline is located in Georgia, about, we're estimating, how many miles of coastline are in Georgia? So 0.8%, that's close enough to 1% that I can comfortably use 1%. My 12,383, I'm going to round that to 12,000. And then I can say, all right, so let's do what we did before. How much is 10% of 12,000? That's 1,200. Remember, you divide by 10. So that means 1% of 12,000 is 120. So there are about 120 miles, 120 miles of coastline in Georgia. Here, I've got all these colors. Let me see if I can make my answer itself a little different color. I'll make it a light blue like the ocean out there, the coastline. Oh, missed a little piece right there. Boom, got the power. All right, so again, take a look at whatever you need to look at. Rewind if you need to. If not, we're moving on. Problem number 13. 67% of 8.7. Now, I love this problem because 67% is about 66%. Now, you might be thinking, hang on, everything we've talked about so far has been like round to 75 or round to 70. But 66% is a great number because that is 2/3. So 66% is 2/3 of something. Now, this is another one where you look at it and you say, okay, if I'm going to use 2/3, what would be a number really close to this that would be easy to get 2/3 of? And that would be the number 9. 2/3 of 9 is what I'm going to work with for my estimation. And 2/3 of 9 is 6. Right? Take 9, divide it by 3 pieces. You get 3. There's your 3. Take 2 of those, and you have 6. Over here, 10.5% of 238. So my 238, I'm going to make 240. My 10.5%, I'm going to make 10%. And wow, we did so many of these yesterday. You probably look at that right away and go, oh, 10% of 40, 24. All right, number 17. Students at Monroe Junior High School sponsored a canned food drive. 7th grade collected 129% of its goal. So A, about how many cans did the students actually collect if their goal was 200? So this is a problem where I'm going to look at starting by rounding my percent. And the way I'm going to round my percent, I'm going to take my 129%, and I'm going to say that that's approximately 125%. And 125, pardon me, 125 is a great number because I can get 100%, and I can get 25%. And that 25% is the same as having 1/4. So having 1/4 of something, a lot of numbers are really compatible with that. So now I'm going to apply that to my 200. So with my 200 cans, if I look at 100% of that, so 100% of 200 equals 200, and 25% of 200, which is the same as saying 1/4 of 200 is 50. So far, they have collected 250 cans. That's if their goal was 250. Part B says, what if their goal was 500? So if there was, or 595, or what if they'd collected, excuse me. Let me start again. What if their goal was 595? So if their goal was 595, I should edit all these mistakes out, but heck, you know what? We're not about it all being perfect. We're about learning the math. So 595, I would round to 600. And then I would apply the same thing. 100% of 600 is 600, and 25% of 600. So let me show you my thinking on 25% of 600. If I was doing 25% of 600, the first thing I would do is I would ask myself, what's half of 600? So in my head, I'm going, well, half of 600 is 300. Great. What's half of 300? Well, that's 150. And so that means 25% is 150. When you take half of half, you're taking 25%. So I've got 150 here, which means they have collected 750 cans. Roughly, about. Remember right here, the words about tell us we're doing some estimation. All right, last one on this page, number 19. Is an estimate for the percent of a number always, sometimes, or never greater than the actual percent? Well, the answer is, it is sometimes greater, is the estimate. And it depends on which way you round. If you take, let's take 22% of 200. If I was to round that up to 25% of 200, I would get 50. If I was to round that down to 20% of 200, pardon me just for a moment while I fixed my horrible percent sign there. Much better. If I was to round down to 20% of 200, I would get 40. The actual answer, 22% of 200, is 44. And we could do that. Here's my thinking on that. 22% of 100 is 22, so double that is 44. So notice if I round up, my estimate will be higher than the actual. If I round down, my estimate will be lower. Okay, let's move on to the next page. Okay, so we are asked about a survey of 510 students. So the first thing I'm going to do is I'm going to say, okay, that's about 500. Determine if each of the following is a good estimate. 125 students prefer cats. So here's cats at 24%. I'm going to think about that as being 25%. So I'm thinking about 25% of 500, which is a fourth of 500. And in my estimating of this, I would ask myself, what's 25% of 100? That's 25. Since it's 500, I would need 5 groups of 25, which is 125. Yes, that's a decent estimate. Dogs. Dogs get to be purple or blue today. Blue dogs. All right, dogs. 38%. I would think of that as roughly 40. So now I'm doing, here's my dog work right here, 40% of 500. Well, 40% of 100 equals 40. This is 500, so I would need 5 groups of 40. 5 times 4 is 20, so 5 times 40 is 200. 200, yes. And finally, fish. Fish get to be, I don't know, fish are going to be green, like the algae color, I suppose. 20%. I'm going to keep the 20%. That works well. So for fish right here, I'm doing 20% of 500. Well, 20% of 100 is 20. So I would need 5 groups of 20 for 500. That's 100. No, that's way off. 150 fish, way off. That's a no. Here's a little bit of review work. 1,200 equals 4a. So we're asking ourselves 4 times what number makes 1,200. So we're going to divide that by 4. We're going to divide that by 4. We're going to get 300 here. 12 divided by 4 is 3. So 1,200 divided by 4 is 300. That's how much a is. And then we always want to check that work. What is 4 times 300? Well, 4 times 3 is 12. So 4 times 300 is 1,200. And our check works. We know that that worked out. All right, number 35, last of our problems here. Margarita created the design at the right. She created the design with 8 equal-sized rectangles. Write a fraction in simplest form to represent the yellow portion. So there's a yellow. There's a yellow. So there are 2 yellows out of 8 pieces, which means 1/4. So 1/4 of the rectangles are yellow. Okay. Review whatever you need to review. And then I've got some extra work for you to do today for some additional practice. And I'll explain that in class. Thanks very much. And if you ever have any suggestions on how I can make the videos better, please let me know.